polynomial remainder theorem. So this is kind of a shortcut to get the remainder when dividing polynomials without actually doing the division. So let's do an example. If someone were to ask us, okay, well, let's do what's the remainder when you divide 3x cubed plus x squared plus 4x plus 7, okay? And you're dividing it by x minus 1, okay? So how do we find this? Well, we are going to plug in 1, okay, to this polynomial, okay? It's not negative 1, okay, because if it's in the form, if the whatever we're dividing by is in the form x minus a, we're going to be taking a, not negative a, okay? So if we would have, if it was x plus 1, okay, we would take negative 1 because x plus 1 is the same as x minus negative 1, okay? So we would take negative 1. We just want to get that out of the way so there's no more confusion. So if we plug in 1, that's 3 times 1 cubed, which is just 3, plus 1 squared, just 1, plus 4 times 1 is just 4, plus 7, and that gives us 11 plus 4, so our remainder should be 15. So now let's test this out. So now let's do some long division with this, okay? So we have x minus 1, okay? What do we need to multiply x by to get 3x cubed, okay? We need to multiply it by 3x squared, so this is where we start, right? So now x times 3x squared is going to be 3x, wait, let me redo this, x1. So let's look at the first term, okay? What do we need to multiply x by to get 3x cubed? We need to multiply it by x squared, so we go over to the x squared spot, and remember it's 3x squared because we need to match it, right, the coefficient as well. So we're going to do 3x cubed and negative 1 times 3x squared is negative 3x squared. And remember, we're subtracting this, so we want to distribute the negatives. Now these cancel out, right? 3x cubed plus, or negative 3x cubed, right, is equal to 0, plus x squared plus 3x squared is 4x squared, okay? So now let's find the next one, okay? So how do we match 4x squared? Well, we multiply x by 4x. So 4x squared plus, and remember, we got to bring down the 4x, okay? So we got plus 4x. I'm sorry, okay, let's go over here. So now negative 1 times 4x is negative 4x. And when we're subtracting, we distribute the negative. It's very important. So now we have 0 plus 8x. Now we're going to bring down this 7, right? Plus 7. And now we're going to say, okay, well, x times what is equal to 8x. We just multiply it by 8. So we have, that's an h, okay, plus negative 8. And, okay, yeah, just pretend that's an 8. Minus, distribute the negative. We get 0 plus 15. And look at that. Our remainder is 15. So the polynomial remainder theorem is a very easy way to find your remainder without actually doing the division, and I'll show you in a minute why this is important. Okay, so how can we use the polynomial remainder theorem? Well, we can use the polynomial remainder theorem to find missing coefficients if we are given a factor. So I set this up right here. So we have 4x cubed plus 7x squared plus some coefficient x plus 11. So this could literally be anything. This could be any value, except if we say it has a factor of x minus 2, okay? So how do we do this? Well, this is actually just this equation. We know it has a factor of x minus 2, right? And it's times, we'll just say g of x, okay, just some other polynomial, okay? Okay, and how about this? Just an easier way to look at it, we can set this as f of x, just for simplicity. So, we know that f of x is equal to x minus 2 times some other g of x, some other polynomial, okay? So, how can we make this as simple as possible? How can we find this missing coefficient and just keep it as simple as possible, okay? Well, what we can do is we can say, okay, if we know the factor, we know that if we make x equal to 2, then we know if we make this equal to 2, then that expression is going to be equal to 0, so just multiplying by 0. So we know, okay, if x is equal to 2, the expression is equal to 0. So just set it to 0 and plug it in, okay? So 4 times 2 cubed plus 7 times 2 squared plus 2c plus 11, okay? And now we kind of have an equation that we can just simplify, right? So that's 4 times 8 plus 7 times 4 plus 2c plus 11, okay? And so we have, that's 11, that's just about 11. Now we have 32 plus 28 plus 2c plus 11. So if we add everything up, that's what, 60 plus 11 is 71 plus 2c is equal to 0. And we can subtract 71 from both sides, so we're left with negative 71. And we divide by 2c. So that tells us that c is equal to negative 35.5. So yeah, look at that. So c is equal to negative 35.5. So with knowing the polynomial, which coefficient's missing, and its factor, we can basically, using the polynomial remainder theorem, we can figure out what that missing coefficient is. Hey guys, so today we covered what division with polynomials is, long division with polynomials, and the polynomial remainder theorem. So next video I'll be talking about how polynomials look when graphed. So thanks for watching, feel free to give feedback and check out Khan Academy. Peace.